Hello, ni hao and sawadee-ka. A very good afternoon to all of you. Welcome to LINXDays Southeast Asia 2022, live from Singapore. I am Cecilia, the Regional Marketing in charge at LINX Singapore. Thank you for taking your time to join us here today. LINXDays is our very own annual event. It connects us with you from the region to get to meet us and the updates of our products. 2022 is an exciting year for us because besides this webinar, you get to see us in 2 other industrial events as well. For those who have went to NetCon 2022 in Bangkok, Thailand, thank you for visiting us and it was a pleasure to meet you. Well, if you have missed us in Bangkok, there is an upcoming event this October, the ITAP 2022 at Singapore Expo. We will be displaying the latest products and technology, including LMI. So today, we are thankful to have the team of experts from LMI Technology to share with us the newest launch of Gocator series. They are so hot and fresh from the oven that we are all excited to find out what are the amazing features and applications that measures the impossible. We have invited 2 very experienced speakers, Peter and Zach, who will reveal the impossible secrets of Gocator 2600 and 5500 series. Before we go into the main course, let's start with an opening speech by our Managing Director of LINX Singapore, Mr. Henry Chia. Let us welcome Henry.
Hello everyone, welcome to LINXDays 2022 for LMI Technologies. This is our online marketing event for our customers. In each of these meetings, all of you will understand each manufacturer better. The latest technology developed by them will be showcased and highlighted. The speaker will introduce these products and you will be able to see if this information can help you in developing the next machine and meet your manufacturing needs. Today, we have partnered with LMI Technologies in Southeast Asia to present this webinar. From its humble origins in the 1970s with the lumberjack industry, we can see how LMI has gathered strength on the back of evolving trends and technology to become the leading manufacturer of 3D systems today. They have developed and acquired the key elements of the 3D business to pivot to where they are right now. By innovating, reimagining constantly, and disrupting current products today, LMI has shown the industry what it takes to be the leader of the pack. Today, I want to talk about 3 challenges they are facing manufacturers of 3D scanning systems and their customers. Number 1, there's always a need to scan at higher speed. Customers require higher speed for higher throughputs. Factories are required to increase their scanning speed and to inspect more. Demand is increasing and everyone's ROI is arcing upwards. You simply need to scan faster than ever before. Number 2, we need to scan at higher resolution. Our gadgets are getting smaller and slimmer. Product designs require more exquisite finishes. You need to pack more components and chips into a single piece of PCB. Wire pitch is getting blurred for our eyes to discern. You don't just need to scan more. You need to scan at higher resolution. For example, 2K, no less. Thirdly, we need to scan more challenging surfaces. Design has become very complex and hence the manufacturing requires materials that has gotten harder to inspect and scan. This includes OLED surfaces, flex PCB, multi-layered transparent materials, printed and hybrid electronics. It's getting common to scan such applications. But I'm sure today, these challenges will be addressed by LMI speakers with their new 3D solutions. I hope you'll find this session beneficial as the webinar will equip you with the knowledge for your 3D needs. I want us to scan faster, more precisely, and scan smarter. Let's innovate and create successful solutions for our industry. Without further delay, I'll now pass the time to the next speaker from LMI.
Thank you, Henry, for the opening speech. Before I hand you over to Peter and Zach, I have a top secret to tell you. You know that Gocator 2600 is not officially launched yet. So today, we are all very lucky to be the first to know. Without holding you up any longer, let's start to the focus of the webinar today. Over to you, Peter.
Thank you, Cecilia. Thanks for having us here as speakers today. I will just share my screen and on the way. So I'm Peter Wiklund. I'm the Business Development Manager for LMI's Technologies. I'm responsible for sales in Southeast Asia. I'm going to just give you a brief overview of LMI technologies, our scanning technologies, our sensor families today, and especially on our new products, the G5500 and the G2600. And then Zach will tell you a little bit more about interesting applications, give you some details on what you can do with the sensors here. So let's just go ahead. LMI makes inline 3D scanning and inspection sensors. They're used in automation, quality control, and optimization applications. We have been in business for quite a long time. Since 40 years back, roughly, we started in the end of 1970s. We've sold quite a large number of sensors worldwide for different applications now since then. And well, yesterday or today, don't know, we're still employing people. We were about 416 people. Our headquarters is in Vancouver, Canada, and it looks like this. It's a beautiful place on a sunny day, and it can be a little bit more gloomy when we come into November, but it's mostly beautiful. We do have a number of regional offices all over the world in all time zones, and we do have distributors in all time zones, definitely. So what do we do different? Well, what we do is chip level engineering. That means that we design our sensors from the chip up. We don't buy cameras and put into our sensors. We build cameras. We don't buy lasers or laser drivers, laser pens. We build laser pens, build them from the diode up. Everything we do is smart technology. Smart can mean that a sensor by itself can actually solve an application and give you a yes or no, good or bad decision, or just output some measurements. It can also mean that it's a smart way to actually connect a couple of sensors together, make it easy for you to actually get a wider field of view or scan something in 360 degrees. Everything has to be simple user experience driven. So there is a web server in all our sensors, and you can connect to it just by using your browser, and you will have your sensor at your fingertips. In Vancouver, we do our manufacturing, and we have now manufacturing capacity to meet high volume product demand. That means like several hundred sensor orders, and we can ramp up quite fast. And even in these days of where products are hard to get or components are hard to get, we have a very good procurement backbone that means that we have somewhere around 6 to 10 weeks of lead time on our sensors, where I know that other manufacturers, they have like 6 months worth of lead time. We do have dedicated technical sales and support in all our time zones, and wherever we can, we look for progressive partnerships where we build special solutions when it makes sense to do that. So our flagship product lines, that's of course the Gocator. And it comes with 3 different technologies: laser triangulation, structured light, and line confocal imaging. And that's sort of the latest addition to our scanning technologies. This means that we have a white light source that illuminates the target. It creates a spectrum of light wavelengths, and each white light wavelength will be focused back on a position on a CMOS array. And this means that we use sort of the light spectrum here to resolve a measurement range. So it works like this, roughly, where you have the different distances being focused on the detector here. So when you have a nice clear surface, you have a strong peak. If the surface is opaque, it will be a lower peak here. So our sensor families, they consist of Gocator 1300s, single point sensors. Come in a large variety of sensors from 20 millimeter range up to 2 meter range. Our workhorse is the Gocator 2100 and 2300. That's VGA resolution and megapixel resolution sensors. The higher resolution 2000 pixel sensors along the laser line is the 2400. When you need to go even faster, but still with a high resolution, you go to the 2500 series. This is about 10 times faster than the 2400, but also with a 2000 pixel resolution along the laser line. Now we're coming to the interesting parts, because it says 4K here. So this is the 2400, but with a 4K imager, and not really the high speed of the 2500, but it's faster than the 2400. All these are laser triangulation based sensors. We do have a Gocator 200 as well. That also is based on laser triangulation, but that's a specialized sensor for wood scanning. When we go over to the structured light sensors, it's the Gocator 3000 sensors, and they come in fields of use from, say, a cube of 40 millimeters up to a cube of 150 to 200 millimeters. Not really large field of view, but with high resolution. And then we get into the Gocator 5000, the new addition here with the line confocal technology. So the advantages of our smart sensor technology is that we can actually scan, measure, and control in just one unit. This means that you don't need any external controllers. You set it up very easily using a laptop and you fire away. Factory calibrated, no external lighting required. We have a big suite of tools on board, so we can perform interesting measurements and calculate different intricate distances. And there are filters on board, so you can actually improve the quality of the data that you're looking at, or actually highlight the kind of data that you're looking at. The Gocator 5000 series, our patented line confocal imaging technology. This is ideal for metrology type of applications that requires high resolution and high speeds. We're talking about X resolution, that's resolution along the line here of 2.5 microns, and Z repeatability in the measurement range down to 50 nanometers. That's really good. So best in class performance on challenging material structures, multi-layered, curved, transparent, and shiny materials. And it runs our next generation vision inspection software called GoPixel. So what's unique about this here? It simultaneously generates topographic data and 2D intensity data. That's what our normal Gocators do as well. But in this case, you also get 3D tomography. That is multi-layered 3D geometry. You capture about 1,720 data points per profile. We can scan at speeds up to 16 kilohertz. That is where you have PC acceleration available to capture objects in motion for inline inspection. Easy to mount, low sensitivity to surface orientation, and so on. It identifies defects such as delamination, scratches or dust on the surface or inside a laminated glass, for instance. It handles any surface type, mirror-like, glossy, opaque, translucent, curved, soft, fragile, or porous. And it scans materials with any color combination. So you can get 3D, 2D, and tomographic data from up to 8 stacked surfaces in one scan. That means that we can do thickness measurement through clear layers, coatings, and air gaps. We acquire profile line of data points simultaneously at speeds covered similar to 2000 confocal point sensors. And that's pretty good. And then we have multi-sensor networking capability under development that will come a little bit later. And to get the high speed that can be interesting, you need PC acceleration. So the sensors are typically bigger than what you're used to with the normal Gocators. If we take a Gocator 2380, for instance, that's one of the biggest of the Gocators, or the 2490. You have a sensor that weighs about 1.5 kilos. The smallest one here, the 5504, weighs 4 kilos. The 5512 and 16, they are around 20 kilos. Measurement range, 1.1 millimeter, 3 millimeter, 5.5 millimeter here. So it's all about small parts inspection. Field of view is also quite small, but it also means that you get really high resolution and repeatability. Next in line, we do have the Gocator 2600 series, the 4K line profiler. So here we're introducing a complete family of sensors from the 2630, 40, 50, 70, and 90. This is something that is going to be launched within the next days from now. They are ramping up and getting ready for production here, so that you can start looking at some really interesting scanning solutions. High resolution measurement of microscopic features, defect detection on EV battery modules, printed circuit boards are typical examples of where this sensor will be used. A 9 megapixel imager, 4,200 points per profile over the laser line. That gives you, for instance, X resolution down to 70 microns for 47 millimeter of field of view. Or if you have the biggest one with 2 meter field of view, you're down to 0.5 millimeter resolution. Full field of view, you can scan at 300 hertz. And as usual in the Gocator families, if you reduce your active area of this imager, you will increase speed. So the Gocator 2600 can scan field of views up to 2 meters. And now replacing, for instance, dual sensors where you need to have 2 2400s or even more 2300 sensors to cover a certain field of view at a certain resolution, you can now look at the possibility of maybe scanning with a single sensor over a large field of view. This is really interesting. And of course, we have our usual native support for multi-sensor networks. It's all there. It outputs a single high-density 3D point cloud ready for measurement if you need that, or just a laser line and a profile. And you can scan 360 of a target and in multiple views, or you can mix different 2600 sensor models. That means that if you have a thin, wide material like a particle board or something, you can have different resolutions on the edges where you may want to see greater details. They're built on LMI's leading smart sensor design architecture, so you will recognize yourself when you start up these sensors. And of course, it's our standard, easy-to-use, web-based interface. You have the I/O connectivity, everything is there. Just a quick comparison here. I know that Zach will tell you a little bit more about this. Here to the right, you see a scan using a Gocator 2450. And to the left, you see a Gocator 2650 here. And as you can see, that's greater details on the 2650 here. Looking into some applications, just a quick overview here. Of course, inline parts inspection on a conveyor, looking for good and bad. The sensors themselves can output the result, good or bad, if possible. Box volume gauging. The high resolution means that you can use a large field of view sensor and large measurement range of sensor to actually scan both big and small targets with adequate resolution. Looking at food processing, like in baking products or in poultry or protein management, you may need to see greater detail on both sides and on top before further processing. Robotic pick and place, where you might have had to use two sensors to actually identify all the products on the conveyor. You can now use one sensor to scan like multiple lanes on a conveyor belt like this. Looking at EV battery inspection, where you most certainly needed a couple of sensors to actually scan the field, the width of the product. Now you can use one sensor to replace two sensors here, and you still have the resolution of details on your each battery cell that you see. In automotive, for instance, robotic assembly here, you see the robot is positioning the roof into a certain position, and then the sensor helps guiding the robot to the correct position on the car body. Road and rail inspection is also a difficult area to scan in, where you have difficult light conditions, you have high speed needs. On a rail, for instance, you have a shiny surface on the top where the wheel is grinding off all the rust, and on the sides here you can have quite rusty target coloring. Looking at some line confocal applications here to sum up this here, multi-layered tomography here, typically phone display assembly, where you see multi-layers in one single scan. A difficult application is looking at the side where the glass meets the frame. You have to scan both a metallic, non-transparent part and a glass transparent part. And you get really nice data out of this. Looking at ball grid assemblies or arrays, we deliver metrology grade resolutions using, for instance, the 5504, where you can actually get very high resolution on the height, on the size of these each individual ball here. And to sum up here, just showing you some scans that we've done on, say, foam glass, where we have a big scratch here. It's 3 micron deep. So it's, you will feel it with your fingernail, but hardly see it. And we have scanned a paper, office paper, where we printed an O on it, and the O looks like this. And you see you have quite a high resolution on the imaging of the height of this O here. So that's a little bit about the overview from this here. So over to you, Zach.
Okay, thank you, Peter. So let me share my screen. Okay, so good afternoon, everyone. So today I'll give you a brief introduction about the latest industrial application examples using our Gocator 2600 and the 5500 series. LMI Gocator laser profilers, they are designed for 3D measurement and control applications. Laser sensors can inspect almost any type of moving targets. And with LMI's built-in smart tools, measurements can be made on different type of materials. So now with our latest addition 2600 to the Gocator family, Gocator sensors can address a broader range of applications. So here are the Gocator 2600, the new lineup of the latest laser displacement measuring technology. And as Peter previously mentioned, these are the 4K line profilers. These all-in-one 3D sensors features ultra-high resolution, ultra-high accuracy, and so this time the all module releasing their blue sensors, except for the largest one, the 2690, it is red. And also you may have noticed that this time the new released sensors, they all have relatively wide field of view. Well, yes, but the good news is that the new sensor, the Gocator 2610, it will also come out very, very soon. So we will keep you posted. Please stay tuned. So here's the 3D scan comparison between Gocator 2400 and the Gocator 2600. So the right one is 2450. The surface quality is very good. However, the 2450's X resolution doesn't allow the topography of the sample to be examined, to be in a necessary detail. So we can see here that the edges around the corners, they are kind of washed away already. And the other side, the Gocator 2650, with a 9 megapixel imager, it offers ultra high resolution. Improved X resolution means more details. So now with the Gocator 2600, we are taking the 3D scanning to the next level. Here's an application in the EV battery. And in the EV battery industry, traditional 2D machine vision is not always suitable for the quality inspection. Since 2D is not able to provide height information, in addition, 2D vision is not ideal for inspecting the low contrast objects like these ones. And the 3D solutions has better performance, and it represents the future. So Gocator laser profilers are widely used during the various stages of EV battery manufacturing to achieve optimal product quality and the maximum capacity. So for example, the post-welding surface inspection, during the laser welding process, it may cause many kinds of defects, and such as these small bursts, bumps, and pinholes. And so it is vital to conduct a post-welding surface inspection to ensure the battery's optimal quality and its safety performance. And usually the key to success of defect detection lies in getting high quality 3D images. So Gocator 2600 is able to generate an ultra high resolution surface data and for the successful measurement of microscopic features, such as the bumps and bursts on the battery. And in EV battery industry, cell surface inspection is also a challenge. The inspection involves the use of 3D smart sensors to accurately detect the surface features and flaws. And usually our end users, they always have a strong preference of high X resolution sensors. And the Gocator 2640, the new 4K resolution sensor, is a perfect fit for the surface inspection because more details means closer examination. In addition, the Gocator 2600 has an improved optical performance on the shiny metal surface because the new imager is very sensitive. So if the exposure is set optimally, so we won't get much noise around the edges. Besides, in some scenarios, with enough X resolution, we can use the 3D sensors to replace the traditional 2D cameras for the width measurement. And for applications which require multiple sensors, LMI offers multi-sensor approach with easy setup and easy synchronization. For example, this application, the EV battery module inspection, usually we need the body mode, like two Gocator 2430s are used in a wide layout, two sensors here to cover the large field of view. Now, the Gocator 2600, it has much larger field of view and the measurement range. For example, this is a Gocator 2630. It has almost twice the field of view than 2430. So now with the higher X resolution, 2630 can be used to replace two 2430s. So basically it's more data, but less money. And usually the dimension applications are very easy within our Gocator sensors software capability. So you can see, we can count the radius of the batteries. So the dimension measurement should be very easy. And here is an application in automotive industry, the brake rotors. Here we have a Gocator 2630 sensors. And when it comes to making brake rotors, there's a lot that goes into the testing the surface quality to ensure that the brake rotor is in good shape. And the Gocator 2630 is the optimal solution. Scanning the parts, a rotor, see in the factory, the rotor surface texture and the colors, they shift all the time. But with an improved imager and the lens, the 2630 can always produce clearer and sharper scans. The sensor provides excellent resolution to measure the detailed features like the cracks, scratches, roughness. So this Gocator 2630, it turned out to be very effective in inspecting the brake rotors. And here we have a short video of Gocator 2640. The sensor is scanning a motorcycle clutch friction plate, a critical component of automotive transmission system. And as you see, the scanning is very straightforward, and getting high quality surface data is not much of a challenge. So after the 3D surface is captured, the sensor can perform inner diameter measurement. And here, this is the height measurement. Gocator 2600 is more than just a sensor. It delivers not only the good scanning performance, but also provides the stunning range of uncensored measurement and the inspection capabilities. It's still the same application. Here, the sensor can optionally let you count the number of the friction pads. Here we use the surface blob tool. This tool can extract the targets, the friction pads from the 3D background surface and allow you count the number of the blobs. And here you can see we can get each blob's area. The surface blow-up tool also lets you detect the surface defects, such as uneven or excess material, gouges on a relative uniform background, in either 3D map data or intensity data. And combined with the new version of the onboard measurement tools, Gocator 2600 brings a high level of measuring performance to the end users. And as always, LMI technologies, we will improve the 3D scanning and our software tool to simplify the new applications in the automation industry. And our new light confocal sensors, the new Gocator 5500 series. Gocator 5500 series it introduced the line confocal imaging technology to the LMI's proven industry-leading smart sensor design platform. So now basically, the Gocator 5500 and the laser profilers, they share the same easy-to-use web-based interface now. And with the same building measurement tools, the same I/O connection method, and the confocal sensors become more user-friendly. And the sensor, it doesn't require the 10 gig network card anymore. And with the new PC acceleration, the Gocator 5512 and the Gocator 5516, they can achieve 20 to 30% speed increase. And here the sensor is scanning the cell phone edge. Gocator 5500's off-axis arrangement, it allows the sensor to avoid unwanted reflection from the shiny surfaces. And this unique design also permits multi-layer scanning. For other optical inspection systems, optical sensors on the market, they cannot provide this scanning capabilities. Here you see the Gocator 5500, it can see the edge of the cell phone and capture the glass and the frame simultaneously. Although the target is fully transparent and curved, the sensor is still able to capture a very high quality 3D image. And as shown, the sensors are able to return multiple layers of data on the translucent material. And they are well suited not only for collecting 3D data, but also the intensity images. For the light confocal sensors, when the target is in its measurement range, the sensor's 2D image is always in focus. And here, the second one, it shows the topography image of the smartphone display. So for display manufacture, there are a lot of defects during the assembly, and how to inspect those defects inside the display, it was a big challenge. Now with the Gocator 5500, we can solve this issue. See here, here's the measuring 3D curved glass. This was done with the Gocator 5512. And in semiconductor industry, Gocator 5500 is widely used in semiconductor industry for 3D inspection. And it is popular at many stages of fabrication process because the light confocal technologies, it provides semiconductor manufacturer with a non-contact, ultra high performance solution for the precision 3D inspection. And here we have an application about BGA. This is a very small chip, and there are like thousands of tiny solder boards on this PCB board for connecting the chips and the PCB. And in the past, it would take significantly more time to measure these solder boards and with a microscope. Now with Gocator 5512 or Gocator 5004, we can complete measurement of all solder boards in just minutes. And check this picture. Because of the off-axis design, the sensor provides exceptional signal quality for measuring microscopic features such as height of the BGA boards. And the upgrade to the Gocator platform allows the desired measurement to be done with LMI's building tool sets. Now the new light confocal sensor, it can accurately measure the ball height, the ball position, and other dimension information of the ball. Here in the medical industry, the Gocator 5500, it provides a highly specialized vision solution for the most challenging complex measurement applications. Here, the sensor is measuring a small tube. The small plastic tubing with a diameter less than 10 millimeter is used in a wide variety of medical applications. Because the tube walls are very thin, so the manufacturing tolerance for thickness and the concentricity is typically very high. And the Gocator 5512, it offers fast and non-destructive alternative to the common process of cutting the tube samples for the optical measurement of thickness. And in addition to the thickness measurement, some defects like delamination, scratches, and particles on the surface or inside, they can all identified as well. And this page is about glue inspection, and usually the UV protective glue is transparent, which makes it very difficult for the optical sensor to inspect the dimension of the defects. And due to excellent performance and the scanning transparent and curved materials, Gocator 5504 and the 5512 can be used to accurately measure and inspect the 3D glue height and volume before it is cured. And the Gocator 5500 is ideal for quality control of hybrid electronics and coated transparent substrates to detect defects. And to sum up, light confocal imaging technologies allow Gocator 55 to scan practically any material type. And now combining the LCI's unique optical approach with our Gocator's proven inspection software, our scanning and inspection solution lead the industry in solving challenging applications across a variety of markets, such as consumer electronics and battery and pharmaceutical and semiconductor and medical industries. And given the high accuracy and the repeatability of our Gocator 5500 and Gocator 2600 sensors, now our customers have an increased demand for a great stage. So now introducing our new photon optical inspection system. This system utilizes a granite table for the machine stability. The system also has high resolution encoders for X, Y, Z axis and high performance servo drivers. So basically with the high accuracy multi-coordinate controls, this photon can offer great measurement accuracy and efficiency. And additionally, the photon is also an image analysis and surface metrology software platform. See, basically this all-in-one software can handle sensor configuration, the stage motion control, and the point cloud acquisition and the data analysis. You can complete all these steps in just a few minutes. It also generates a standardized scanning report for your surface analysis and for your measurement results. So it really makes every type of inspection easy and flexible. And here we have a video clip of photon and Gocator 5512. The sensor is scanning an AR goggle. Photon has a vacuum table, so you can use a suction to hold the workpiece in place during scanning. And you see the photon system It can perform multiple scans and then automatically stitch all these scan data into one single 3D image. This is the lens of AR goggle. Here it scans the parts multiple times, and it provides us an automated method for accuracy 3D stitching, which is cool. Okay, back to you, Cecilia. I'm done.
Thank you, Peter and Zach. That was an exciting and informational presentation. Did you guys actually learn anything through the session? So which one can actually scan through the multiple layers of the cell phone or the reflective parts of a car body? Oh well, the next segment is the Q&A session. I bet you have many questions on hand right now. So Peter, Zach, and our team will try to answer all of them within the given time. For those questions that we are not able to answer them during this session, don't worry, our team will keep in touch with you. Okay, come, let's start with the first question. So the first question is from Yan Chao. So, okay, any of the Gocator product ranges measure depth of defects, example, crack lines, or to perform a measurement of a part accurately, which replace micrometer or vernier calipers?
Just quickly here, I would say the ranges, the depth of the defects and the width of the defects will be limiting maybe a little bit, because we have to be able to see into the defect, the crack line. The 5500 series would probably be the type of product that I would look at, and then replacing a micrometer, that would be, I would have to look at the actual application here to say if we do have a suitable product for it. But the 5500 series would probably be the type of sensor that I would look at. You agree, Zach?
Yes.
Yeah.
Okay, thank you.
Especially for the small crack lines. Yeah. Good.
Okay. Okay, the next question is, can the Gocator be used for roughness measurement, like RA 3.4?
Yes, the Gocator sensor, it was widely used for the roughness measurement. For example, the application example I mentioned earlier, the brake rotors, we use the Gocator sensors for the roughness measurement. And I'm not sure about the actual RA requirement, but we also use the for the really fine surfaces. We also use the Gocator 5500 for the roughness measurement. Like I'm sure, like Gocator 5012, it can perform roughness measurement for like RA 3.5 surface. It should be okay. Yeah, we have done the same type of application last year. Yeah,
Okay,
and we even have our own developed algorithm for this type of measurement. Yeah.
Okay, and the next question we have here is, do we need to send back Gocator 3D sensor for calibration yearly?
That's an easy one. No, you don't.
Okay, so the next question we have here is, do we need to install any software to work with Gocator 3D sensor?
No, that's not necessary. For Gocator sensor, it's an all-in-one sensor, and basically you just need to connect the sensor to your computer and open your web page, then you can start using the sensor. Yeah. So there's no software required. However, with the new Go Pixel, I think if you need to use the PC acceleration, then yeah, you need to install the Go Pixel firmware to accelerate your 3D sensors. But yeah, but without the software, you can still use the sensor. Yeah.
Okay, thank you, Zach.
It's very easy to use. Yeah.
The next question we have here, how many job or configuration files can the Gocator store?
We can store more than 50 jobs in the Gocator sensor. I mean, we can save the job configuration files inside the sensor, and also we can upload the job files from the local computer. And yeah, you can switch the job and change the job's recipe in no time with our SDK. Yeah.
I think it also depends a
I think
little bit
that's-
on the size of the job files, I guess, how big the different job files are.
Okay.
How
Okay, the
many
next
how many
question.
different tools or filters that you're actually having in each job. There is a limited amount of memory space available.
Okay. The next question we have here is, does Gocator have SDK support to develop own user interface?
Yeah, we do.
Yes.
We do have the Go SDK that is available for users to write their own interface to the Gocator.
Okay, the next question we have here, for BGA measurement of 50 micron diameter, what is the largest FOV and at what scan speed in mm per seconds?
Well, usually for the BGA applications, we use Gocator 5512 or 5504. And the FOV of the sensor for 5512, the FOV is around 11.6 millimeter. That's the line width of the Gocator 5512. And the scanning speed, it depends on like the 50 microns diameter. I'm not sure about the height of the BGA balls, because usually we will like reduce the sensor's Z range to accelerate it to make the sensor working faster. So the scanning speed for the BGA usually depends on the height of the BGA balls.
Okay, the next question we have here, how does it detect bubble and air gaps?
Bubbles and air gaps.
Yeah.
So for bubble and air gaps, usually we use the Gocator 5500. And because the sensor, it has the multi-layers, it can detect the different layers of the parts. And like when we use the sensor to scan the parts, you can see the top layer and the second layer. and you can measure the width or the thickness of the part to see to detect any types of the gaps, air gaps between the different layers to see if you have any bubbles. So usually, if you have big bubbles in between the first two layers, then you can you can see the thickness of the part. It changed significantly.
Okay, interesting. Okay, the next question is that, will there be inaccuracy if a scan path is disrupted midway during the scan?
What would the disruption mean? Is that like a conveyor stopping and then continuing again, or that would typically be a case where it doesn't really matter. The sensor will, if it's connected to an encoder system, it will detect that the conveyor has stopped and it doesn't continue to scan all the time. And then it continues to scan according to its settings then to scan a complete product. So I guess that depending on what the disruption is, yes. But in most cases, it will not really matter. Do you agree, Zach?
Yes, it depends, like how the path it was disrupted, right? And how the sensor was triggered is also it really matters, right?
Okay, we have another question here. For the 2600 series, with field of view around 400 mm, can it be used for transparent object?
Actually, I have done the test with the 2630, and when using 2630, when we tilt the sensor along its x-axis, we can use the sensor for the transparent objects. But with the field view around 400 meters, I think for this range, we need to use 2670. I don't think it's a good option to use 2670 for that transparent object. For this type of application, I would prefer to use two 2630 in wide layout, and we use the two sensors to get it for this type of objects.
I think it's always difficult to say that optical triangulation is a solution for transparent objects. So I would agree completely with Zach there. You have to be careful. You have to look at the individual application and see if it's feasible at all. Transparent objects is really difficult.
Okay, we have another question here. Can it measure translucent liquid on a PCB board?
There was another question before that. What are output from the Gocator 3D sensor? Can we get intensity grayscale image in addition to 3D point cloud? Yes.
Yes.
That's always possible. So can it measure translucent liquid on a PCB board? Question for you, Zach.
The answer is yes. Yeah, with our Gocator 5500, yeah, you can find the translucent liquid on the PCB board. Yeah, without much challenge. Yeah, it should be easy.
Okay, I think it's our last question. Time is almost up. So is there any plan for ML or DL in 3D measurements?
Yes, there is. We do have acquired a company recently called well, that really just do deep learning, machine learning algorithms. That is for use with any input of sensors like 2Ds, 3Ds, X-rays, whatever. You can read measurements from a hard drive or directly from a sensor. And we do have this type of sort of like system and solution that works outside of the Gocator at this point. We haven't included any of this in the tools of the Gocator at this point. I hope this answers the question. Do you have any further there, Zach?
No, that's it. Yeah. Good. Yeah.
Okay, there's one more question here. Shall we just clear this one last question here? So what are IP resistance level for general Gocator?
IP resistance level. So sorry, I don't get it. So the IP resist. So what is IP resistance level?
Isaac, Sean here. I think it may be referring to probably like IP6 or IP7 production. Whether it's weatherproof.
It's IP67. That's all our Gocators are IP67. Or what is it, NEMA 4 or something like that, the US equivalent. I guess that was the question, I hope.
Okay.
Waterproof.
Okay.
IP67.
Right.
Yep.
Okay, that's the end of our Q&A session. Okay, thank you everyone for your participation in the Q&A. We are sure that you want to explore more about the new series of Gocator 2600 and 5500. In our final segment, our Sales Director, Sean Chang, who will be sharing a summary of today's webinar. Welcome, Sean.
Hello, good afternoon, everybody. So I'm Sean Chang, the Sales Director at LINX Singapore. So thank you, Peter and Zach, for the informative presentation of the new lineups of the 2600 and the 5500 series. So very interesting application shared by Zach. So perhaps you may have similar challenging projects as well. Now, 3D has gained traction over the years, helping customers with more challenging applications, whereby 2D vision has its limitations and not able to solve so easily. So if you have projects or applications needing 3D solutions, please come and discuss with us. Our sales and engineering will be at hand to help you out. Now, usually we would have the new demo Gocators with us, whereby you can bring your samples and let us do an eval together with you. Unfortunately, it's not with us right now, but there's an opportunity where if we can get your samples, we will send it to the nearest LMI office and they can do that evaluation for you. All right. Now, the 5000 series are currently available and the lead times are roughly about 6 to 8 weeks. Now, for the 2600 series, they will be available from September onwards. And it's roughly about 8 to 10 weeks at the moment. And we'll keep you informed about that. So thank you everybody who has attended this webinar, and I hope you found it interesting and start to think what this technology can help you solve today's problem. All right, now I'll hand over the time to Cecilia for the closing. So thank you very much.
Thank you. Thank you, Sean, and all our presenters today. For more information or requests for demo, do not hesitate to contact us at sales@links-sg.com or call +65 6842 0500. And here's a quick look at our offices in Singapore, Malaysia, and Thailand. Drop us your inquiries and we will get in touch with you. With this, we have come to the end of LINXDays Southeast Asia 2022. For all the attendees today, we will be keeping in touch with you via a follow-up email after this session. If you have further questions, you may reply to us via the email. And if you are or will be in Singapore between 18th and 20th October, come and visit us at ITAP 2022 at Singapore Expo. For more information of the exhibition, follow us on our LinkedIn page, Links Singapore, or check our website, www.links-sg.com. Thank you once again. We truly appreciate your participation today. Stay safe, take care, and we will see you in 2023. Bye-bye.